So now we have example 4, graph f of x is equal x power 4 over 3 plus 32 x power 1 over 3. First, the domain of the function is from minus infinity to infinity. For the x-intercept, put y is equal to 0, so when y is equal to 0, we get x power 4 over 3 plus 32 multiplied by x power 1 over 3 is equal to 0. Taking x power 1 over 3 as a common factor, so we left with x plus 32. So either x is equal to 0 or x is equal minus 32. So for the x-intercept 0, 0 and 0 minus 32. For the y-intercept, we let x is equal to 0, so we get 0 and 0. So now the y-intercept will be 0, 0. For the symmetry about the x-axis, we need to replace, for the symmetry about x-axis, we need to multiply the function by minus 1. So minus f of x, this will give us minus x power 4 over 3 minus 32 x power 1 over 3. If you compare this one with f of x, it seems they are different, so there is no symmetry about the x-axis. For the symmetry about the y-axis, we need to replace any x by minus x. So f minus x will be minus x power 4 over 3 minus 32 multiplied by minus x power 1 over 3. If you compare this one with f of x, it will not be equal. So there is no symmetry about the y-axis. So for the vertical asymptote, we need to evaluate. There is no vertical asymptote because this one is, for this one there is no vertical asymptote, also for this one. But for the horizontal asymptote, we need to evaluate the limit when x approaches to plus or minus infinity. This will give us plus or minus infinity. So we said there is no horizontal asymptote and also there is no vertical asymptote. For the f prime x, to use the first derivative test, we need to differentiate. So it will be 4 over 3 x power 1 over 3 and 32 multiplied 1 over 3 x power minus 2 over 3. So if you simplify this, you will get 4x plus 32 divided by 3x power 2 over 3. So f prime x is equal to 0, that means 4x plus 32 is equal to 0. So x will be equal minus 8. Minus 8 is in the domain, so it is a critical number or a critical value. For f prime x does not exist, you will take 3x power 2 over 3 is equal to 0, that means x is equal to 0, also a critical number or a critical value because it is in the domain. So now, if you draw the table, you will take from minus infinity to minus 8, then from minus 8 to 0, then from 0 to infinity. So from minus infinity to minus 8, f prime x is negative, that means our function is decreasing. From minus 8 to 0, f prime x is positive, so that means our function increasing. For the interval from 0 to infinity, f prime x positive, so that means our function increasing. So here, since we have decreasing then increasing at minus 8, so fx has a relative minimum at f minus 8. To evaluate f minus 8, just replace here minus 8 power 4 over 3 plus 32 multiplied by minus 8 power 1 over 3. This will give us, it is equal minus 48. At x is equal to 0, there is no change on the sign of f prime x, so there is no relative extrema. Let us consider when f prime x, if we evaluate f prime x when x approaches to 0. So here we have this derivative. Limit of f prime x when x approaches to 0 from left, this will give us minus infinity. So go to this function, replace x by, we have x approach to 0 from left. So that means we need to take a small number which is negative and close to 0. This will give us a big number which is with negative. So this is minus infinity. And limit of f prime x when x approach to 0 from right, take a small number which is positive but it is close to 0. Replace x by it, then you will get a big number which is infinity. So since here we have two different signs of the f prime x when x approaches to 0, we conclude that f has a cusp at 0 and 0. So we said that f has a cusp at 0 and 0 because the derivative has two different signs when x approaches to 0. So now to graph our function, we will use whatever information we have. So we have the x-intercept 0, 0 and 0 minus 32. So here we have the point 0, 0. Here we have 0 minus 32. Then there is no symmetry about x-axis. There is no symmetry about x-axis or y-axis. no horizontal, no vertical. Then we need to draw something here. We have a relative minimum at -8, which is -48. So here at -8, here we have -48. We'll draw something which is here relative minimum. So we have this point, we have this point, we have the point 0, 0. We need to connect all these points, and we need to put in our mind that this function has a cusp at the point 0, 0. So from 0, 0 to -8, -48, you will connect this by this line. Then here you will have a relative minimum. Then at 0, 0, this function has a cusp. So you will draw something like this one, because this function has a cusp at 0, 0. Then you will complete your drawing. Then we have problem in our book. So we have 2, 43 and 44. Determine where the slope of the tangent to the graph of the given function has a relative maximum or a relative minimum. So here we have two functions. We need to know the slope of the tangent at which point it has a relative maximum or relative minimum. Here we ask about the slope of the tangent, not about the function. So we need to use the second derivative, not the first. Because here, if the question says determine where the graph has a relative maximum or relative minimum, we'll use the previous way. But if it says the slope, that means we need to use the second derivative, not the first derivative. So f prime x, I will do 44 and 43 is an exercise. So 44 f prime x will be 4x cubed minus 12x. So this is our equation, which is equation of the tangent line. We need to know is this equation has any relative maximum or minimum. So we need to differentiate first. So the second derivative will be 12x squared minus 12. Solving this one is equal to 0. That means 12x squared minus 12 is equal to 0. So 12, take it as common factor. X squared minus 1 is equal to 0. So x is equal plus or minus 1. So now we need to check the second derivative on this interval. So from minus infinity to minus 1, then from minus 1 to 1, then from 1 to infinity. So from minus infinity to minus 1, the second derivative is positive. So our function f prime x increasing. From minus 1 to 1, the second derivative is negative, so f prime x decreasing. Then from 1 to infinity, the second derivative positive, so that means f prime x increasing. So we conclude f prime x has a relative maximum at the point minus 1, so f prime minus 1, which give us 8. Similarly, f prime x has a relative minimum here at 1, so f prime 1 is equal minus 8. So the slope of the tangent line has a relative maximum at minus 1 and a relative minimum at 1. هنا السؤال يسأل عن السلوب of the tangent line، هل فيها relative maximum أو minimum. فعلى أساس كده استخدمت المشتقة الثانية. بينما لو كان السؤال يسأل عن الفانكشن إذا بستخدم المشتقة الأولى. And the last theorem, theorem 4.6.2, the sole critical number test. Suppose C is the only critical number of a function f within an interval I. If it is proved that fc is a relative extremum, then fc is an absolute extremum. يعني إذا كانت الفانكشن فيها critical number واحدة بس اللي هي c، وكانت عند الكريتيكال هذه إنه الفانكشن عبارة عن relative maximum أو relative minimum، إذا على طول بتكون هي نفسها